This is Mr. Martin. This video is for Precalc Honors. We're talking about logarithms and their properties. This is section 3.4, video number 2. So continuing with the examples, let's take a look at example 5. And what we want to do is use our laws of logarithms and the values that are given to us below for these 4 different logs to evaluate each logarithmic expression that we're given. And we're going to use these to calculate all the other different logs for parts A through F. So starting with part A, we don't have the log of 8 up here, so what we're going to do is we're going to change this to the log base 2 cubed, and we have the log base 2. So now using our properties of logs, we'll rewrite this as 3 log base 2, which then becomes 3 times the log of 2 is 0.301, and our answer to the log of base 8 then becomes 0.903. Alright, at any point if you want to pause the video and work these out, or work out as many as you think you can, feel free to do that, and then just fast forward through to check your solutions. So moving on to part B. Using our log properties, we're going to rewrite this as the log of 4 times 3. So that becomes the log of 4 plus the log of 3, which becomes log of 2 squared plus log 3. And continuing, that becomes 2 log of 2 plus log of 3, and now we have it broken up into values that they've given to us. So it's going to be 2 times the log of 2, which is 0.301, plus the log of 3, which is 0.4771, and our final answer becomes 1.0791. Alright, part C. Again, using our log properties, we can make this the difference of 2 logs. So log 5 minus log 7. And they gave us the value of log 5 is 0.6990. And the log of 7 is 0.8451. Which then becomes negative 0.1461. Alright, part D, we have another log of a fraction here. So we'll separate it into the difference of 2 logs. Log 3 minus log 14. We have the value for log 3, but we don't have the value for log 14, so let's go ahead and break that up. So we have the log of 3 minus, notice the parentheses here, log of 2 times 7, which becomes log 3, minus the log of 2 plus the log of 7. And now we have it broken up into values that we have. So the log of 3 is 0.4771 minus, and the log of base 2 is 0.301, and the log of base 7 is 0.8451, and our final answer is negative 0.699. Alright, moving on to part E. Let's rewrite this as a fraction 6/10, so that becomes the log of 6 over 10, which becomes the log, divide by 2, so we get 3/5, log of 3/5, and we have the log of 3, and we have the log of 5, so that becomes the log of 3 minus the log of 5. The log of 3 is 0.4771, and the log of 5 is 0.699. 0.9, and our final answer becomes negative 0.2219. Alright, and the last part for example F. Again, let's rewrite this as a fraction. So 1.5 is 3/2, so that's log of 3 over 2, which can become the difference of two logs. So log 3 minus log 2. It's 0.4771 minus 0.301, and that becomes 0.1761. Alright, so as always, if you have questions about those, make sure you get those answered in class. Let's move on to the next example here. It says use a graphing calculator to approximate the solution of 2 log x equals x squared minus 3. So what I'm going to do is I'm going to go to my y equals, and I'm going to plug in both of these expressions. So 2 log x. There's my 2 log x, and I'm going to plug in x squared minus 3, and I'm just going to do a zoom 6 to take a look and see what we have here. That's our zoom standard, and there's our 2 log x, and there's our x squared minus 3, and it kind of looks like they intersect somewhere over here. We know this 2 log x isn't going to cross the y-axis. That's going to be an asymptote there. And we know they are going to intersect somewhere over here. So I'm going to zoom box. So zoom number 1. And I'm going to go up here a little bit and over here a little bit and hit enter. And then I'm just going to drag this down just past that intersection. Drag that over just past that intersection and hit enter, so that'll zoom in on those two spots. Alright, so again, here's going to be one intersection. That's going to be a solution of this. And then here's the other intersection, which will be another solution. So we're going to go second and calc, and we want the intersection, so that's 5. And it wants the first curve. So we're on the 2 log x, so I'm just going to hit enter. And then it automatically flips to the second curve, x squared minus 3, so I'm going to hit enter again. And now it's looking for a guess. So we can scroll over a little bit closer to the guess if we want to. Normally you can just hit enter and it should figure it out. So let's go ahead and hit enter after we scroll closer. And it's calculating. Alright, and it tells us that the intersection here, so one solution to this is 1.88, comma 0.55. So that's one solution. So let's go ahead and do second calc again. And we want intersection, so number 5. And now let's scroll over by that other point here. So again, notice it says we're on Y1, so let's hit enter. Now it moves us over to Y2, so we'll hit enter again. Again, you can scroll a little closer to that intersection if you want for your guess, and hit enter. And there's our second intersection point, 0.0316 or 0.032, and negative, looks like about -3. So we've got 0.032, and we'll just go with -3. Alright, so there's our two intersections. Alright, moving on to number 7. You have deposited $1,000 in an account that pays 6.25% interest, compounded continuously. So we know that's going to be our A is equal to P times E raised to the RT. How long will it take your money to double, and how long will it take to triple? Alright, so let's start with how long it's going to take to double. So if we're starting with $1,000 and it's going to double, so we know that A is equal to P times E to the RT. So if we start with $1,000, we're going to end up with $2,000. So 2,000 is equal to 1,000. Here's our principal. Here's the amount that we have. E and our rate is 0.0625, and we're going to solve for T. So let's solve that for T. Let's divide both sides by 1,000. We get 2 is equal to E raised to the 0.0625 T. Now, if I take the natural log of both sides, I'm going to get the natural log of 2. When I take the natural log of this side, the natural log and the E are inverses, so they cancel each other out, equals 0.0625 T. And solving that for T by dividing both sides by 0.0625, I get that my time is about 11.09 years. Alright, and for it to triple, so if we notice here, it doesn't really matter what amount we start with. This number here represents doubling, so if I want to represent tripling, I would just start with a 3 there. So I've got 3 is equal to E to the 0.0625 T. Again, if you want to start with 1,000 and make that 3,000, feel free to do that. And again, we'll take the natural log of both sides. So natural log 3 equals 0.0625 T. We'll divide both sides by 0.0625. And for this one, we get T is about 17.6 years. Alright, as always, let me know if you have questions about that. And moving on to number 8, it says the number Y of endangered animal species on a protected wildlife preserve from 1990 to 2004 can be modeled by Y equals -117 plus 159 natural log T, where T is between 10 and 24 years, with T equal 10 corresponding to 1990. During which year did the number of endangered animal species reach 342? So we've got our equation here, and we want to solve for T when Y is equal to 342. So I have -117 plus 159 natural log T is equal to 342. So let's add 117 to both sides. I have 159. Natural log T is equal to 459. Divide both sides by 159. I get natural log T is equal to 2.8868. I would use at least 4 decimal places so we get a fairly accurate answer. And we'll rewrite this in exponential form. So I have T is equal to E raised to the 2.8868, which is about 17.9 years. So during which year did the number of endangered animal species reach 342? So this tells us it's going to be 1990 plus 17.9 years, which makes it 2007. Alright, so go back and always make sure that you're answering the question. Alright, so that's going to be the end of this video. As always, make sure you get your questions answered, and we'll see you next time.